And here we go.
We're living on a disk, floating through space, with a tiny sun.
Hey, I'm FTFE and welcome back to the channel that does to stupidity what Justice League did to Joss Whedon's career. That dude's not working in Hollywood ever again. Welcome back to Monday Night Debate, because we still have to debate the shape of the Earth, you know, even though we've been to space and just flew a little baby helicopter on another fucking planet. Congratulations to the Mars team for achieving something that is a first for humanity, a powered flight of a craft built on Earth on another planet. Fucking amazing. Can't wait to hear the denial from the flat Earth side. Talking about the flat Earth side, tonight joining me again we have Effed Up World. Joe, welcome back to the channel.
Thank you. Good to be back. And hello, everyone. I'm actually excited to be here.
Right. So first of all, I do want to ask your opinion on the Ingenuity flight.
I thought it looked like a little drone flying on Mars, I guess. I mean, that's what it is, right?
Yeah. It's absolutely incredible. It paves the way forward for much better missions on Mars. You know, we can send robotic drones there to help do stuff like build cities, because we now know that we can fly craft on a planet with 1% the atmosphere of Earth, which is pretty damn incredible.
Yeah, so maybe
people in chat.
Go ahead. I'm
PhD
sorry.
Tony, Quitty's a Sprinkler, Fohammer, Mandevil, Stellarium Celestra, Manny Keen, Raven Zero. Hello to Flerfs there, I see you. Jose Rees, Sparky, nice to see everybody there. Thank you very much. If you would like to help the channel, the best thing you can do is share this stream, see if we can get a bigger audience in tonight. Right, Joe, so you've been asking to come back on. Is there any specific areas that you want to talk about?
There's a few things that you know, in our last conversation we were talking about the rotation or the lack thereof of the Earth, right? And
the definite rotation, yeah.
Had a couple I had a couple things that maybe from a different perspective we could look at them and, you know, see something a little different. I'm not saying I'm going to convince you or something, but something having to do with the stars rotating, and not that it would be the Earth. Like, I know that's what everyone believes, is that when they look up at the stars and the stars appear to be moving, that's actually the Earth spinning or rotating that's causing it, that apparent thing that we're seeing. But there's some things that kind of clash with that a little bit in my mind. One of them being the speed that everything in space has to be going. I mean, like, we build a rocket, we started out building it at 0 miles an hour, and it's sitting on the launch pad, not moving, you know, 0 miles an hour. And we have to accelerate the rocket to a high velocity in order to go into that place, to go into space. So to me, that lends a little bit of credit to that the sky is rotating, you know, like that it's actually turning. But
right, so so you think because the fact that rockets have to reach, like, you know, 200 kilometers now, 200,000 kilometers an hour, whatever it is, to be able to gain orbital velocity, you think that's credence to the fact that the sky is moving? And let me get your logic correct here. That is because the rocket has to catch up to the speed of the sky.
Very much so. Yeah, that was a good way to describe what I kind of am saying. Look at Craig. Look at Craig.
So, John,
I'm
I'm
already
just going to
giving
need
him
a
a headache.
second. I'm just going to need a second. So, here's one issue with that I
What's
can
the
just
acceleration
think of.
for?
The acceleration is to get into an orbital velocity. You need to be
Yes, so what I'm
traveling at
saying,
a
that
certain speed
velocity,
to not crash back into Earth, to be fast enough
yes,
to miss the Earth. So,
yes, that's
one of the main problems that I have with what you've just said, I mean, there's many. I may clip that and make it a short, to be honest.
yeah.
Uh,
Let's
but
do it. Talk about them.
one of the main issues I have is that rockets don't rotate in the sky at 15 degrees per hour. In fact, they go considerably faster. Um,
Yes, yep. Like
so,
the
so
ISS going over,
yeah.
right?
So why
Yeah,
would
that
the
goes over
rockets need to
fast.
go faster than the sky which is rotating? And if we're going to say that the sky is rotating, then we have to say that it's the same rotation as I say it's the Earth, which is 15 degrees per hour. And a
Okay,
rocket
and I
wouldn't
can
have to
actually,
go
yeah,
very
that.
fast to be going at 15 degrees per hour in the sky, right?
Let me give a like kind of a, I guess, a comparison or analogy. You know how we say, or you say, I'll say this, the Earth is rotating, and if you are flying in an airplane on the Earth, you're actually not touching the Earth, but the atmosphere, the air on the Earth is rotating with the Earth, so it's the same as if it was just still, right? You know what I'm
Yeah,
saying?
yeah,
We could almost like compare that with the sky and say the opposite, whereas once we go into that orbital velocity and you're actually in space, like we have in order to do that acceleration from 0 miles an hour up to that speed, we have to use a bunch of fuel, right? But
yeah.
once they're in space, almost no fuel is needed to continue that whatever trajectory that it's
Yeah,
on, and they can
once you're
adjust
in
it and
an
whatever.
orbital velocity, because of the fact there's no friction in space, as long as you've got that
Yeah.
momentum, you conserve that momentum and will stay in an orbit. Orbits do tend to
Yes.
decay over time, and you may need to make small adjustments, which the ISS does at time to time. Um,
Yep.
Only this year, I
But
actually
it's
had to
very
make
little.
several adjustments to avoid some potential space junk. Yeah, but it is you're right. It's very little, but generally, once you're
Yeah.
in an
So
orbit, you don't need to expend any more fuel. Which is why you can
so
have
kind of like a
something like
helicopter.
a geostationary satellite in orbit, like the GOES-3 satellite, which was an American telecommunications satellite launched in the 1970s, and it stayed in operation for nearly 40 years. Um,
Okay.
and you couldn't do that if it was something that required fuel. So yeah,
Exactly. So once something's up there, I guess we could compare it almost like with a helicopter. If you just go off of the ground, 10 feet with a, or 100 feet with a helicopter, and you don't have to try to keep up with the Earth rotating, do you? You just,
no,
because the air is moving with, if the Earth's
exactly.
rotating, the air's moving with it, just as if nothing was moving if in that situation. So I kind of am looking at the sky in the same way, and that's why I've been saying so much that it's moving, it's turning, and not everything in the sky would be necessarily moving at that same speed that the stars are turning at, because that
So
obviously is just one rotation per day, just like,
uh, okay, so
you know what I'm saying.
let me ask you a question. So is there a point where in your mind where the sky starts turning? It goes from we know we can go up a few hundred feet and the sky isn't turning because that just
Yeah,
doesn't happen. So is
I
there
would
an
say.
elevation? Is there an altitude that you get to where all of a sudden space or the sky or whatever's up there is turning?
I don't wouldn't say it's like specifically like at an exact elevation, but it's basically when there's almost no air at the Carmen line. And it's like
Right. So if
how high is that? 60 miles or something like that.
yeah, so if it's space that's moving, what would that matter? Because there's still no friction in space due to the fact there is no air, right?
Yeah. There's no what
So
I
so how
say,
would you
and I
determine
know.
that the
Oh,
sky is moving? How would you
I
say,
observe it.
okay, but is there a point where you would be, still, and then you go up a little bit further, and all of a sudden you're also moving at 15 degrees per
Only if you
hour?
want to
Uh,
stay up there. I mean,
and
if you send a
what
rocket
would
straight up, it's just gonna come right back down. You have to go sideways.
cause you to have that motion?
You're saying like if like a spaceship type of thing, or like the ISS,
Yeah,
say,
say
or
that all right, say that you were just below the Kármán line, that then you went into the Kármán line and you're into this space that is moving. Would you be dragged along with it?
no, there's no
Right.
friction. So let me just say,
So
like, if
how
you
do you know
let's
it's
say we had a
moving?
rocket, let's say we had a rocket and we were going to send it just see how high we could get it off of the surface of the earth or whatever. And so we were just going to send it straight up in the air. It's just going to fall right back down after it runs out of fuel. It's just going to fall right back down on the ground because it's not moving it needs to be moving parallel with the surface of the earth, uh, very much, I think, like the stars appear to be doing. It has to be moving parallel, like not it has to be moving sideways in order to stay there, right?
So right. So things
And I
that are in the
understand.
sky
Oh,
that are moving. So you say you see the stars and stuff moving at 15 degrees per hour across the sky. So why
yep.
are they moving if you wouldn't then move if you went into that area of space? What's causing the stars and everything to move in that area of whatever it is that you say is moving? What's the force to keep the stars and other heavenly bodies actually moving?
I couldn't say that I know that. I mean, I guess what I believe is that's a like another nature, another type of nature other than the earth. Like,
Yeah, I mean, but
I'm
that's
not saying
completely
I understand it.
speculative, right? So
Yeah, that's sort of, but it is based on some observations that I've brought up. You know what I mean? One being that we all throughout the year we all see the constellations moving throughout the year, right? You
yeah,
know that, and then each night we see the stars moving their position, going over us, moving each night. So we all observe the sky turning, whether or not we uh, come to the conclusion that it's the earth spinning that makes it appear that way, or if the earth was stationary and the stars were actually moving. But we all observe that, right? I think you can agree with that.
I mean, from the point of view of Earth, of simply being on
Yes,
Earth
that's
and
because,
looking
yeah.
up, the stars
Yep.
appear to rotate above us. Okay,
Yes,
but
that's what
but
simple. Yeah.
that one particular observation falls apart when you start adding other things to it, like the fact that you can view very different stars from different locations. That there's different stars that you can see through different points throughout the year, and there's no explanation for why all these other movements of the stars would be happening, other than the 15 degrees that we see every night. How would you
Hmm.
explain the complete change of the stars over the months and things like that if the sky is simply just moving at 15 degrees per hour?
Well, you're just saying like how we like part of the year we'll see Jupiter and Saturn, and then part of the year we
Yeah,
won't see it.
and there's a
Okay.
good question about the planets that Scythe DK wants me to ask. We'll get to that in a minute.
Okay. And yeah, actually, I would love to talk about the planets because I see them to be different than all the other stars in their motions, at which I because they have like retrograde motion, and
Uh-huh.
the all the stars appear to be doing
Which is
one
also
type of motion.
explained by the heliocentric model,
Yeah, that's what.
and
Yeah,
and
that's what
all of the
I've heard.
movements. The fact that we can see the 15 degrees per hour on a daily basis, and the fact that we can see the change in position throughout the year and throughout the centuries, that is
Yep.
all mapped and predicted as part of the heliocentric model. It's all completely explained with
It's
no
just part of
issues.
that idea. Yeah, but
It's
at the
not, no,
same time,
a
the
model isn't an idea. A model is a mathematical description capable of making predictions accurately. If it
Yeah,
doesn't
sure,
make an accurate
sure. But
prediction,
it doesn't
then
mean that
it's not a
it's
representation of reality. And it's an extremely good way for us to determine what reality is, because reality needs to follow a set of rules. It's as simple as that.
yeah, yeah,
And
true.
if we can mathematically describe those sets of rules and use what we have derived from reality to create a predictive, based algorithm, that is what a model is. It's derived
What if
from
I point out
reality. It's not saying this is reality. It's simply a description of reality around us that we can use to make predictions.
hmm But what if I was to say that parts of reality have to be ignored in order to make these predictions that you're talking about? One of them
There,
being
okay,
like,
what parts of reality would need to be ignored? Because I don't
well,
honestly
one
think
would
there is
be,
any.
uh, and this gets into instruments and putting faith in instruments or that go against what we perceive and experience on the earth with our bodies.
Say that
Like
again.
what I'm
Sorry.
saying, and I know I'm beating a dead horse, but the your senses and perceptions, and I know you're gonna say, well, take off your glasses and you can't see well. Is the world fuzzy? That's not or blurry. um I understand that aspect of it, but we all do live and walk and work and drive on the ground that's not moving. Like I'm saying, to us, to our
You've
apparent.
never drank enough, obviously. Never gone
Yeah, well, you
drinking with
brought that
with
up
the
too.
Navy.
I've
But
never been in the
the
Navy.
thing is, you can measure that the ground is moving. You can
with
actually use tools
with
to
some
measure that.
equipment, right?
Yeah,
With
and
a
that's what
Yeah, a
equipment's
gyro.
for.
But I
You know,
don't
you
think I
it's
personally
like
don't
it's the
think that.
same as saying that you can't see a virus with the naked eye, so clearly viruses aren't actually real. We can't with our senses detect it in any way. But of course,
Well, we
viruses are
kind of
real.
can
One's just
because we
wiped
get
out three
sick,
million
right?
people. Well, no, but you still
We
can't
kind
see
of
the virus.
can.
You can see people being sick, but you'd have to just
Yeah,
make the assumption that it's a microscopic creature that's doing it. We only know that viruses exist
yeah, and I
because
get
we've
that.
actually been able to
I would
look at
say
them.
to
You know?
use a microscope, right?
Yeah, and
And
that's a
and
tool that we need to evaluate certain parts of reality. We cannot determine reality
we're just
at the
enhancing.
microscopic scale without a
Yeah,
tool
when
to
we
do
look
it.
through a microscope,
But
all we're
these are just
doing is we're
enhancing the
and
world for me.
oh
That they
yeah.
they are just enhancing the world for me. Look how bloody blind I am.
Yes, no, and I'm not, I totally agree with what you're saying, but at the same time, something optical is, if we magnify in or zoom in on something, if we're using optics that aren't like creating digital, additions or something, if we're actually just using optics like a magnifying glass or, a microscope to look at these things, we are getting an accurate representation visually of what it is, but we're able to look much closer, right?
Yeah, that's what tools are. With our own abilities, though, with our own senses, we can't
Yeah,
determine
and so
those
what I'm
things.
saying is looking through a microscope doesn't go against our senses,
Neither does using a fiber optic gyroscope go against our senses.
but it does though.
No,
And
it doesn't.
I'm not saying that the gyroscope is not measuring something. I'm saying that the gyroscope is saying that the earth is moving, but our senses are saying that the earth's not moving.
Okay, well,
Like just in a very general.
our senses also say that infrared light doesn't exist. Microwaves
Yes,
aren't a
yeah.
thing. X-rays don't exist. Gamma rays
And I'm
aren't
not
real.
saying that they don't.
These are all
I
things that we cannot use our senses to determine about the world around us. Try using your senses to determine the direction a magnetic field is traveling. You can't
Yeah,
do
no,
it.
I don't think you
But
can.
these things are real, and we have
Yeah.
tools to be able to detect them. So if I was to use my senses, magnets aren't a thing. We all know that's not true.
Well, they are because we have magnets. I don't,
Yeah,
it's
we
not going
also
against
have interferometric
something,
fiber optic gyroscopes that measure the rotation of the Earth.
or
It's
they
not
measure
going
something,
against any.
or they drift. They drift.
I don't think you understand what drift is. They measure a drift in the Earth,
That's
and
what I mean. That's what I
yeah,
mean.
but there that you would literally have to give explanations for what is being recorded other than the conclusion we get from it being a rotating globe, because it doesn't just measure in two axes, it measures in three. and it shows
Yeah.
the way that it rotates. It has to be a globe. There is no other conclusion you can draw from it. And then you have all other
Yeah,
experiments that can back these things up, like pendulum experiments. Eric, man, there's so many experiments that can determine that the Earth is rotating. Mechanical gyroscopes.
there's experiments that can show that it's not rotating too,
No, there
right?
isn't. And there's no experiments that can show it's not rotating that are valid, that are actually doing
Do you have a cell
something
phone right
proper.
there? Do you have
Yes,
a
I do.
smartphone right there?
Yeah.
Do you have any like a seismograph type of app on there? I got one on
No,
my phone here.
no, I don't. I pretty much just use
It
this for
won't pick
social
up
media.
any kind of movement if I
Yeah,
set
but
it on the
a
floor.
seismograph isn't designed to pick up the rotation of the Earth, so you're not using the correct
No,
tool
that's
for it.
exactly what I'm saying is that I don't think that designing a piece of equipment to pick up rotation, and I know that that's not
But
what it's designed for.
yeah,
It's designed for
pendulums
like an
aren't
airplane.
designed for that. It's just something that shows that it's a fact. You have to have another
I don't
explanation
give
for what's
the same
happening.
credibility
But
to
okay, well,
the
that's
equipment. I don't.
but that's being a bit dishonest because we have to use equipment to do things.
Well, yes, I'm not going to argue with that. I mean, I agree
I
that
mean,
many things
you know
like
what?
Red's rhetoric was,
We can use our senses to see that the rotation of the Earth is happening.
yeah.
Because hurricanes and stuff happen, which is a
Well,
direct consequence of the rotation of the Earth.
yeah.
So it's not
I
going
don't
outside.
think
It's
that
not
that's
going
true.
outside of nature. It's not. It doesn't matter if you think it's the truth or not. Science doesn't really give a damn what,
Well, I
what you
don't.
think is truth or not.
How can you prove that things that happen in nature are because of rotation of the Earth? I mean, is a tornado because of the rotation of the Earth? No. What brings a
it can
tornado?
help.
You know what I'm saying? We don't know everything, and we can pretend that we do. But I think that
But
it's
we
a
know
little bit
a damn lot about
disingenuous to
weather, and
do
we know
so.
the exact reason why hurricanes are formed. It's because of the Coriolis force due to the fact that the Earth is rotating. These things can be
That's
mapped
what
and
you
modeled
think,
out.
you
No,
know.
not what I think. It's what's been determined with science.
Well,
And just
some of
you have to give other. You can't just say, "Well, I don't think it's that." That's where
well, there is a
you go wrong.
place.
You
There is
stop
a
there.
place.
You stop there,
Okay.
and then you don't give an alternative explanation for what you're saying.
Okay.
Well, let me
let
quickly
me
ask
bring
the question
another
that Seif was
aspect.
asking before I forget
Okay.
about it. Seif was asking
Yeah.
what you think about planets like Neptune and Venus in your model. Wouldn't that mean that they are moving at ridiculous superluminal speeds,
Oh, sure. They're probably moving really fast.
like faster than light?
I just well,
They would have to be.
I guess I don't know.
I mean,
They would
they
have to
would.
be moving faster than light.
It would absolutely
Although we can
have
see
to
them.
be. Yeah,
How are they going to move faster than light if we can see them? I don't
because of the
understand what you mean.
distances away that they are. We know how far away these things are, and
No, you think they're that distance away.
oh no, they've been measured.
I don't.
Again,
I don't think that
we
they're.
don't need to think anything. They've been measured.
And that's
we know
where.
how far away they are.
And that's where, if you think you can measure something in the sky, I understand how you
Of
guys
course you can.
come to
There's
these
something
conclusions.
called
No, but
spectroscopy.
listen. There's another way to understand something though too, is that when I look up in the sky, like Polaris, how far is Polaris away? It's however many light years away. But how
Yeah.
could anyone actually know that?
Because it's been
Because
measured.
what if Polaris is not even what if a star is not a ball of gas like our sun, and it's not what?
Again,
It's just, what if
spectroscopy
it's
says
something
that they
else?
are. We can determine not only that
Well,
they're
yours
stars,
is speculation too.
but but hold on. No, it's not speculation. We can not only determine that they are in fact stars like our sun, but we can determine the particular composition and type of stars that they are. Due
How?
purely to the amount of
You're just
energy
saying by
and the type of
looking at
energy that they put out. We
by
know
looking with
we
different
know
equipment.
the reactions that happen due to nuclear fusion. Okay, we know what happens due to nuclear fusion. We know what the byproducts of nuclear fusion should be. So we can look at a star and look at the particular byproducts that are coming from that star and determine accurately the composition and the mass of the star.
Okay,
And
then
it's a
what
known
about flaws
science.
like the like how what is it how galaxies move, and there's an issue with how fast some of the
Oh, I mean that's what they call the
Theory.
crisis in cosmology, and is to do with the
It's
fact
just a
that
theory.
normal gravity doesn't really explain things at a universal
yeah.
scale, and
Yeah,
it
and
shows that there
I don't
is
think we
something else
understand
there.
everything.
No, what
I
we
don't
do
think we
know,
understand it
what we
all.
do know is that there is something there that exerts a large gravitational force in a different way to other things. We don't know what it is, which is why
No,
we say it's a it's something that we can't see because we currently don't have a way to detect or measure it. But
now let me
500, 600, 1,000 years ago, we didn't really have a way to detect or measure electromagnetic waves. Technology advances. So
yeah, I guess let me make room for something that I think we would be intellectually dishonest if we weren't keeping this in mind, and that is that science doesn't claim to know everything, right?
no, absolutely not.
Science doesn't claim that the science is settled, right?
No, absolutely not. But
Yeah, so
we
let's
are at
keep
points where we have enough to say with certainty that we know something to be a fact. However, if new data ever arrives that contradicts this fact, then we
we have
will
to
assess that
accept
data. But no data
or
has
at least
ever been brought up
acknowledge
that
it.
contradicts it, ever, in
Well,
the
and
history
here's
of
the thing
ever.
though. Would you agree that
Probably not.
at some point in time in the past that the collective idea was not the same as it is today, and it was incorrect at some points in the past? I'm sure.
Say that again.
Like our idea of cosmology throughout time
Yeah, of
in the
course.
past,
Technology,
there's
our
been times
technology
when we
is
didn't
now
know
better.
everything,
Yeah, our
right?
technology is now a lot better than it was, so
It
we are
is.
able
It
to
is. I
measure and
agree.
determine a lot more of the world than what we were. Yeah, no,
I
I
agree.
was talking about dark matter, Richard. I know. I just
Okay.
I was looking for the word non-baryonic to describe how we can interact with it with our current technology. Um,
Yep.
so I mean, everything you say is speculation, okay? Based on one simple observation that you have, which is that I look at the sky and the things in the sky appear to move. All right? That's the
Yeah.
one thing that you
That's
really
one thing.
have, right?
But there's more than that. I mean, I live on the earth and I experience it for 43 years so far. And every one of those days throughout those 43 years, I've never experienced any kind of motion. I've never seen it like the idea that we have a solar system, that we're going around the sun. I've never seen anything
What would
like
you
that.
expect? All
I've
right, okay.
experienced the sun going over my head.
Right. Let me ask you this
And I
question.
understand
Let's first
I understand
right. Let me ask this question. Let's assume that you do
how
live
the
on a
globe works,
rotating globe
but I don't
in the
know.
solar system. What would you expect to feel?
Um, I'm getting an echo. Is that
No,
me?
it
Or
must be you. I'm not. It's not coming from my end.
okay. Sorry about that. It was
Sorry.
just for a second and I saw that it said something about internet unstable. So sorry if I'm
That's
cutting out a
okay.
little bit or something.
Right. All right. Okay.
Could you
So
repeat that?
yeah, my question is, let's for a second assume that we do in fact live on a rotating ball in space in the
Okay.
solar system, as the heliocentric model describes. What would you
Yep.
expect to feel? What would you expect to sense?
I wouldn't expect it to be any different. I would expect to experience what we experience. So I have to be honest. I'm just saying
Okay.
if
So
if we're going one
you
revolution
understand the
per day, I
fact
don't think
that
we're going to
yeah
feel that.
yeah you understand the fact that we physically shouldn't feel that motion.
Yes, and I agree
Okay,
with that.
that's fair enough. So then it gets to the point that you have to find a way of determining which it is. You have to find a way of determining whether the observation of the stars moving in the sky in fact means that the stars are moving in the sky. You have to go further than just making that observation and sticking with a
Yeah.
conclusion. And that's why we have tools for measurements. And that's what we go with.
Yeah,
In
and
and
you're
all
choosing
the
to believe
different
the
tools.
tools.
Yeah, but all the different types of tools, some of which are completely separate bits of technology, like centuries of technology apart. There's so many different
Yeah.
tools that can determine the fact that the Earth is rotating, and they all say the same thing. So I'm not just
Yep.
listening to one tool, I'm listening to all of the tools, ever.
And all the tools are disagreeing with you yourself as far as your physical experience on this earth.
Yeah,
That
but
you know what I'm
as
saying?
as we've determined, our physical experience on this Earth would not be able to differentiate between a stationary Earth and a rotating Earth. So we cannot
I agree.
We cannot go with what our physical experience is because it is inconclusive.
But starting at base one, we're born into a world that appears to not move. So if all of a sudden our equipment says, "Oh yeah, it's moving, it's rotating," then we would have to make a choice on the veracity of that measuring equipment, right?
Yes, absolutely, we do. We need to determine whether it's true, and what we do to determine.
And I see a place there for a belief. That's what I see a place there for. And I myself don't believe that 15 degrees per hour on a gyroscope, or more weight on a scale at the equator than the North Pole. I don't see these things to be valid uses or valid reasons to believe that the Earth is rotating.
Not? You need to, rather than just saying you don't see them as valid reasons, you need to explain why.
I observe daily an Earth that's not turning. I do.
But I'm sorry, but that's intellectually dishonest and a bit doublespeak, because you yourself have said that your senses cannot differentiate between a stationary Earth and an Earth that would be rotating. So why would you go with what you observe? Why would you go with what your body tells you if your body cannot tell you the difference?
Because that's where it starts. Do you know what I'm saying? We don't start with the idea that we're spinning.
No, but you're right. It starts, and that's why you then look further. So you then have to do experiments.
I can't ignore it.
Right? Okay, so then you have to do experiments, though, and move forward. So I want to know what your personal standards of evidence are. What would you accept as evidence that the Earth is rotating and not the sky?
That'd be a tough one. That'd be a tough one because everything that I do.
You have to know what your own standard of evidence is. Otherwise, it's very hard to have a conversation about what evidence actually there is. You have to understand yourself what your personal standards of evidence is. So just think to me, just think out loud. What experiment would demonstrate to you that the Earth is rotating and not the stars?
I actually would here's an experiment that I have done and that many people in your audience here have done, and we all come up with the same exact conclusion, but we all see the same results. And here, if you take a camera and you point it up at the sky and you don't move the camera, you just set the camera on the ground, what's going to happen? You're going to see the stars moving. That's an experiment that shows us. But Joe, so that would be a form of evidence to me.
That's the same problem as your senses, okay? You are setting up something that is unable to differentiate between one thing or the other.
No, it's very capable of doing that.
No. Okay, so wait. So you think that if you put a camera on the ground on a rotating Earth, that you should see something else?
I don't. I haven't. The experiment doesn't consider a flat or a rotating Earth. That's not the point. The point is that the result shows us in the viewfinder it shows us.
But that result is unable to differentiate between the Earth rotating and the sky rotating. The same as your senses are unable to differentiate. You see. What do you see on my screen? The stars would apparently move, but that's inconclusive because it's not set up to be able to determine anything else. That is what we would expect to see on a rotating Earth with a camera sitting on the Earth looking at the stars. That's exactly what we'd expect to see.
Yeah, I know, but why would we be concerned? I mean,
because you have to have an alternative hypothesis and a null hypothesis and stuff. You have to think what else it can be. And what you are saying, putting a camera on the ground looking at the stars, is as ridiculous as saying, well, my senses tell me we aren't moving. Because putting a camera on the ground looking at the stars is not a way to determine if the stars are moving or if the Earth is moving, because you would get the same result either way.
I think I see maybe why you're not able to consider it the way that I am is as being evidence or being valid. What's that?
I don't have brain damage.
I don't either. And you know this, Craig. And I understand the joke and the flurf and all that stuff, and it's funny, and I get a kick out of it, and I think it's great that your channel kind of is like very good at making fun of it. I have no problem with that. You know
I know
that.
you got quite angry at my
But when
shorts.
it comes down to it, I am not an idiot. I mean, I definitely think about these things just
Well, why can't you
in a
think
different
of
way.
this? Why can't you think of this? You are only allowing one
I can think
conclusion, right?
I
You
can
are
totally
not
think of this the way you are. I have
right.
my
Well,
whole
that's
life
okay. Well,
for
then
35 years till
you have to come to the conclusion that putting a camera on the ground and looking at the sky will not be able to differentiate between the Earth and the sky rotating because you would get the same thing either way. Do you agree with that?
yeah, you're just saying that basically relative to the earth the sky's moving, relative to the sky the earth's moving.
Yeah,
It's
and
the same both
What
ways,
I'm
right?
saying is whether the sky was rotating or the Earth was rotating, right? You would get the same thing by putting a camera on the ground and looking at the sky. You would get the same result
Yeah,
either way. So you
yeah.
cannot use that as an experiment to determine which one is happening.
Well, but you're the one
You
that's
have to find
adding
ways to
the
actually measure it.
okay, but I guess we come to the technology that we have really makes things a little bit, more difficult to debate because you are gonna give this credence to this 15-degree hour per or
Yeah,
15 degrees an hour. And
I can
thanks,
find out
Bob.
that that's a fact using a couple of egg cartons, a plastic bottle, and a needle and my sink. I can make a gyro compass pretty easy that will not only be able to determine that the Earth is rotating, but also find true north because the Earth is rotating. I don't need big fancy technology. I can swing a pendulum from a really high ceiling and see that the Earth is rotating because it
But
matches a prediction of a rotating Earth. The thing here is that all of the things that
I
happen if
predict
the
that
Earth is
pendulums
rotating,
drift. I'm just kidding. I'm
yeah,
just teasing.
okay, but all right, that all of the things that determine if the Earth is rotating, all the experiments that determine that the Earth is rotating, give the conclusion that the Earth is rotating. You have to come up with
Yeah, I think
alternative
it's
reasons for every one of those experiments and why they all match each other. You can't just dismiss them because you think there's some other physics at work. You need to actually come up with a workable explanation for why a pendulum will drift a different amount based on where you have it on Earth. You have to come up with a workable explanation as for why a gyrocompass can find true north. You have to come up with a workable explanation as for why a mechanical gyroscope and an interferometric gyroscope will both measure a 15-degree rotation in three axes and also the 1 degree rotation a day in two axes around the sun at the center of our solar system. You have to say none of these things are right, come up with alternative explanations that not only explain what we're seeing, but explain it better than the conclusion of the Earth being a globe. Otherwise, you
well,
don't really have
I
anything.
think you make a lot of assumptions.
And we
I
don't make
think
any assumptions.
well, there's one
Well, actually,
I
wait.
guess
That's not true. And here's a big thing that I'm having with flat earthers at the moment, right? Is that science actually
hold on, Craig,
requires you.
hold on. Let me interrupt you. This is funny. You guys see that I'm on the space station here? I got the blue
Yeah,
shirt there.
that's
Um,
it's pretty good CGI.
when I was
Got to
up
give it to you.
there, when I was up there, I brought this book up with me. This really good book, and it was so good I couldn't put it down.
Boom.
Ha ha. Boom boom.
So, um,
So
right, yeah.
there's my joke.
So I've been having a bit. One of my main arguments with flat earthers at the moment is trying to make them understand that science actually requires you to make assumptions. That's part
I
of
agree.
science, right? You have to make an assumption
Yeah, I mean,
because
no,
you need
nobody
to.
comes up with an idea, then
Well, it's not
there
just
wouldn't
that,
be any
but
science. Yeah.
you come up with a hypothesis and then you use that hypothesis to make a prediction, right? And a
Yep.
prediction is an assumption. A prediction is saying, well, I assume that if this hypothesis is correct, this is going to happen. And that's not a problem. Making assumptions isn't an issue in science. It's what you do with that assumption. You test it.
Yeah, I
And
agree.
all the
I agree.
experiments coming from assumptions or predictions match the data that would conclude the Earth being a globe. Nothing, no experiment ever in the history of the world that is designed to detect the motion of the Earth has ever done anything other than detect the motion of the Earth.
Oh, okay. Well, I got kind of a grin on my face because I'm not saying I have an answer for the drift. Like, I'm not saying that I can refute that or say that it's not that or something, but I do have simple things like I was bringing up, put the camera outside, and every time you do it, look through a telescope. Every time you do it, you're going to find that the stars are moving in the viewfinder or the eyepiece of the telescope. Speaking of telescopes, here's this is my
That's quite nice.
one of my telescopes. Yeah, it's a small one. That's do you get like my K&N sticker? That's
nice.
makes it go faster.
Joe
But yeah,
Nobody,
there's
my mic's just down here out of camera. It's just in front of my face. I don't see the point of having it in front of my face. You wouldn't be able to see this beautiful thing, you know?
Hey, you know what? I saw a video or a clip or something of you. Must have been a while ago. You are looking fit. I'm just saying that
I've lost
you've
over a
lost.
third of my
You've
body weight.
yeah
Yeah. So
yeah.
right, here's what happened with that little sidebar. Okay, when I started, I was doing YouTube. I was pretty skinny. Um, I was on a lot of opioid medication for my pain. About 2 months after my channel getting monetized, my
Hmm.
doctor helped me come off of the opioids and change me to another medication. It took a couple of weeks of weaning off of it, being quite ill and stuff, and going through withdrawal. But I came off of the opioids, and
Yeah.
I was on them for nearly a decade. But the major
Oh
side
wow,
effect of that was that
that's a big
my
accomplishment right there.
I feel good about it. I'm so much more healthy in myself. But the months after stopping having opioids, even though I didn't really change my diet, my weight just exploded. I put on about 6 stone in 7 8 months. Um, and I looked at myself one day and I looked at one of my videos and I was like, holy shit, I'm fat.
Just had a big effect.
And then a lot of the flat earthers have started pointing out my weight and stuff. And even though it didn't really get to me, they were right. So I decided to, just work as much as I could to reduce weight. And it's worked really well. And I feel much healthier now. But yeah, I was a fat fucker for a while there.
Good, good. No, I just saw the clip. I think it was actually today, and I
Yeah.
don't know where
The
where I
flat
saw it
earthers
or
call
what
me
it was,
fight the
but it
tight
was just a
shirt. But the
short clip
problem
of you,
is
and I was
that
like,
I
"Whoa,
did
he was
fight the
big."
tight shirt. Yeah, the
Yeah,
flat earthers call me fight the tight shirt. But the
fight the
problem is
tight
I
shirt.
did and I won. So.
I always say, "Fight the pair Earth."
Right, back to the debate. Now, I did see PhD Tony in the chat. Would you like to maybe have a conversation with someone who actually works with stuff in space and understands orbits and gravity and stuff?
I would love to talk about orbits with anyone that knows more about it than I do because there's
Well, he's a doctor,
definitely.
PhD Tony, and his he works with things in space and he's works with gravity being part of his job and he understands
Yeah,
orbital mechanics pretty well. So Tony, if you're there, I'll send you a link to come in on Discord, and maybe you can come
yeah.
in and
I'm
explain some
definitely
things
interested
that
in
I'm not as well equipped to explain as you. Let me just get him an
Mr.
invite.
X. Mr. Y says, "Do you actually know how to focus that telescope?" Yes, I do. Thank you. I get that all the time. You don't know how to focus your telescope. Like, well, let's show me your video then, if of it, like Polaris or a star or something that's in focus. And um, you know that just for example, when I look at Polaris with my I don't know where it is on the screen there. It's not on the screen. I don't know what's going on.
I just see
Um,
sunspots right now.
oh, okay. Yeah, I guess I'm I'm looking at your playback or whatever, and it's timed it bad. So that right there is a Orion. If you're seeing what I'm think you're
Dude,
seeing,
yeah, how can you
it's a
have this
eight
and think
inch
the Earth's
mirror.
flat? Blows my mind.
What was what was that?
How can you have one of these and think the Earth's flat? It's like,
It's a telescope. It looks up at the sky.
yeah, but I mean, do you have an
And you
equatorial
know what
mount?
that one doesn't have any tracking motors or anything, so
Do you have an
that's
EQ
just
mount?
sits still. What's that?
Do you have an EQ mount?
It seemed to cut out a little bit. Do I have any
Like,
what?
do you have an equatorial mount?
Yeah, I own one for that's what this telescope is on, an equatorial mount right here, the
Right. Well,
K&N
you
one
know that the
or
flat
the
Earth's absolutely impossible with that, right?
what is that?
You know that like an EQ mount literally destroys the flat Earth. It's like it's impossible for
No,
an
it
EQ mount
doesn't.
to
It
work.
doesn't.
No, it
It
completely
doesn't.
does. Like 100%. It literally cannot work on a flat Earth.
It
It
literally
wouldn't be
can
able.
work, and
It
I
would
understand.
not be able to track the stars in the same way that
Can
it
I
does if the Earth is flat.
can I
It has to be.
explain something? Okay, you know the of stellarium, right?
Yeah,
Yeah,
based on a globe.
that uh, just like the real world we live in. Well, if we look at like astronomy live, I think that's Red's buddy. I think
Yeah,
he if he's tracking if he's trying to do long exposure photography, he's using an equatorial mount,
yeah. Um,
and I am
the
too. Same thing.
the chat's
It's the
saying
same
that
thing.
that's not an EQ mount. You've actually got an OAZ mount.
Well, I think you might not understand how I have it set up. I'm only using one axis,
Yeah, that's not an
one
EQ mount.
one road. What? That's an EQ mount. Yeah.
No, you're using an OAZ mount, not an EQ mount.
Um, I don't. I can't. I couldn't hear what you said. A what mount? The
You're
first
using
one.
an OAZ mount, not an EQ mount.
Okay.
They're
An
different things
EQ
and
mount
they work
has
in different
one just
ways.
just turns in a circle. That's all it does. Just
Mm,
one
okay.
circle. It doesn't do two.
I mean,
Now
yeah,
I
it
can't.
tracks
I
in
have the
one axis,
capability
but
with that telescope, but if you look down at the bottom,
yeah, but
now
it does,
this that
what you have doesn't have the ability to do what an EQ mount does.
here. Let me grab a different video. I'll show you the one I made. I made one at 45 degrees, and the center of rotation has to point towards Polaris. I'll see if I can find it here. Actually, I don't even know where it is, but I'll still try to find it here. Um, any star in the sky, you can track it with one axis of rotation. You just have to point your camera at it, and you have your latitude has to be the right angle to Polaris, or if you're in the south, to the south center of rotation. Either way, I'll try to find this here. I don't know if I'll have much
So with
luck.
an EQ mount, you can follow a celestial object as it moves through the
I did
sky using a telescope in only one direction. With an azimuth, you move the scope in an east to west direction and slightly up and down. So
see, I don't use the up and down at all. I'm just doing just simple rotation, or I mean one axis of movement.
but that's not doing what it's designed for. It won't track the thing in the sky with one axis because you
Yeah, it
don't
will.
have.
It works great. I know. I think I think you're confused about what an EQ mount is. Actually, Reds knows what it is. Like with as far as
Yeah, and we've pointed
how
this
it
out to
works.
flat earthers many times that
I think you're okay. So let's say we had a camera, and we wanted to build an equatorial mount. We would have to measure the angle to Polaris from our location. That's going to be the first thing you're going to have to do. And where I'm at in Minnesota here, it's 45 degrees. So I mount my camera on basically a very simple axis point that's sitting at 45 degrees, so that the camera spins a circle where the center of that circle is pointed at Polaris.
Yeah,
And
okay,
that's an equatorial mount.
The point is, for an EQ mount to work on a flat Earth, it would have to move in more than one axis of rotation to track
No,
things
that's
in the
just
sky.
what you guys say, but it's not true
No,
at
it's
all.
been mapped out. It is absolutely true.
No, if there's a circle in the sky, okay, because all an equatorial mount does, it's just going in a circle, which is a simple shape. And I know you know what a circle is, that the center
Yeah.
of the circle, the radius is the same
I need
amount all
someone
the way
that works
around.
with EQ mounts to explain it slightly better to you, because even though I know
I've
that
done
they're
a
very
few
different.
videos on it. I think there's
Yeah, and
something
I
that
think you might
you're
be
making
confused about
assumptions about the sky over
No, we're
the
not
flat
making any
Earth.
assumptions about the sky because we have
If you
measured
say
that
that
the
an
Earth
EQ mount
rotates.
won't work,
Yeah, because an
what we
EQ
see in
mount
the
to track
sky
the
is
stars,
just what we see in the
an
sky.
EQ mount to track things in the sky would need, if the Earth was flat, would need to move in two axes, not one.
No,
Yeah, this has been
you're
modeled
you're
out
not
by Slice
understanding.
Barkane. Let me get the video up from
There's something
Sparky.
you're not understanding about the sky, I think. And I actually did a video.
It's something I'm not understanding about the sky. Okay, go on.
Well, Craig, I'm being genuine here.
Yeah,
I
okay.
fully
What is it I
understand
don't understand about
something
the
that I
sky?
can see that
Let me know.
you're not looking at it a certain way. What was
Okay,
that?
well, tell me what it is that you're saying I don't know about the sky.
It's not that you don't know about the sky. It's that, okay, when we look at Polaris, would you agree that any of the stars that are, what are they called? They're above the horizon. I forget what they call them. But any of those stars that we can see that full circle of their rotation, any one of those stars is doing a perfect circle around that center of rotation, right?
Yeah.
Yeah, so
Right.
if you move your camera, if you point it right at Polaris, it's just going to be basically spinning around, and it's just going to be spinning with the whole sky or whatever. But if you aim it at stars further away from Polaris, whether up, down, left, or right, doesn't matter. But if you point it farther away from Polaris, it's going to be doing a bigger circle. Would you agree?
Yeah. Okay, right. Sorry. This animation was made by Slice Barcane to show
Yeah,
how
I've
an
seen it. I've seen it,
EQ mount would
and I
work
don't think
on
that.
a flat Earth. And
Okay,
it shows that it would have to track based on the known position of things in the sky. It would have to track it in more than
no,
one axis for it to work.
there's something that you're not seeing the way I'm seeing it. Is all.
And what is that?
The sky, like let's just take the north because it's easier for me to explain it because I live in the north. I'm more familiar with than I am the south point of
Hemisphere
as a
basis.
center of rotation. But so we're in the north. Anywhere you go, let's say in the United States, anywhere you go, you can film a perfect circle in the sky around that north. I'm just going to say Polaris. I know that it's not exactly Polaris, but what I'm just going to say Polaris because it's easier. So every star in the sky is going around Polaris in a perfect circle. And actually, every star, even in the south, is going around Polaris in that same circular motion, all the way to the south point or the center of rotation in the south. But this is not this circle that we see. It doesn't matter where you are. If you point your telescope or your EQ mount up at Polaris, you're going to be able to track anything in the sky. Now,
Because
if
the
you're
Earth's a
going
globe,
south
yeah.
of the,
That wouldn't
if you
work
go
on a
south
flat
of the
Earth.
equator, let me finish. If you go south of the equator, you're going to see, let's say we're at the equator, and I'll show you what it looks like from there if you're looking north. This is what it's going to look like. I suppose you can't see.
Okay, I'll put you back up.
Sorry about that. Okay, so see how Polaris is right about at the horizon? So we're about
Yeah.
at the equator looking north. And that's what we see. We see that counterclockwise rotation. If we turn ourselves around, we're going to see very much the same thing, but the rotation is obviously going to appear to be the different direction because we're turning
again,
around.
it's only this. I don't understand. You keep saying things that only work on a globe, and I don't understand how you don't see that they.
I don't think that it
work
only
on a
works on a
globe.
globe. I think there's a very good explanation of how it works over a flat Earth.
There isn't one though. Right. Okay.
Well, I don't. Okay, what I'm saying is anywhere you go in the northern hemisphere, above the equator, or you're going to see the stars doing circles around Polaris. Would you agree? I mean, that's what you
Yes.
see. That's what I see.
Yeah.
Now, if you go to
because the Earth's
Australia, you're going to see the same thing, but you're going to be looking at the south center of rotation, but it's south. Like what I'm saying is, I
Again,
made a
which is something that's
video.
only possible on a globe. This is what's blowing my mind here. You
Okay,
keep
tell
saying
me why
things
it's only
that
possible on a globe.
because the Earth
Tell me
is
why.
flat. You couldn't have counter-rotating star trails.
Well, they're not counter-rotating. They're all
They appear
rotating
to
the
be
same
based on
direction.
the.
It's
If you look
because
up at the sky, they appear to rotate in counter-rotation in different ways. That's undeniable.
it's because you turned
And
around.
that would not. Yeah, but okay, that would mean that the flat Earth was inside out, though.
No.
Yeah.
Let me explain. I think you can understand this. I think you can understand because I remember the last debate we had, or last time, or one of them, you had mentioned that at the equator that the stars switch directions. like the
Right.
direction of rotation switches, and that's not true. No matter where you are, if you're in the north, you're going to have the stars rising in the east and setting in the west, correct?
Yes.
And it's the same in the south. It's you turning around that makes them appear to be going a different direction.
Yeah, if you're simply looking, either north or south in the
yeah.
when
so
you're
when you look,
then they but that particular observation of looking in those directions and seeing counter-rotating star trails wouldn't work on a flat Earth. The observation does not make sense if the Earth is flat. Especially if you look at the equator and you can see the two star trails going in opposite directions.
They're
based
not.
On, they appear to be. One's going clockwise and one's going anti-clockwise.
You turned around. You were looking north, and then now you're looking south.
If you look directly at the line when you can look up and see both the star trails, they rotate counter to each other.
No.
When you can see both in the sky at the same time.
Well, they're going to appear to, but you have to have, you're not looking,
because you're looking at both of them.
With like a wide angle lens or something to see if you're able to see both of them. And like if you're, let's say you're at the equator.
Yeah, but you can still see both of them. That's the point.
Yeah, but let me ask you a question. If you're at the equator and you're looking west, right? You're going to see all the way from your left and to your right, all the way to those centers of rotation that are on your right and left at the horizon. You're going to see the stars all going the same direction. They're all going to be setting. And if you turn around, they're all going to be rising. If you face the south, you're going to see them going clockwise. And if you turn around and face the north, you're going to see them going counterclockwise. I hope I'm trying to be clear. And I did a video, and it was a live stream, but I did one that was called the stars rotate in the same direction or something. I'm going to look it up here and see what the title was.
I'm trying to get a good view of the stars that I used to use, but the video seems to have been removed. I
did a stellarium video, or I went to stellarium in a video and explained very clearly what I'm trying to point out. I just have to admit I'm horrible with words. Like my vocabulary and getting the right words out. That's not my forte. So I apologize for that.
Okay. So
I'm going to look up. Oh, go ahead.
No, sorry. I'm going to bring someone else in now. I think PhD Tony's going to come in a bit. If you don't mind, I'm going to bring in Seif DK, who has a few questions for you.
I'm.
You okay with that? Yeah. You disappeared there. You there,
I'm open to whatever you want, Greg. Whatever works.
All right, cool. Oh, right, there you go. You're back.
Are you still there?
Yeah, you disappeared for a sec. You're back now.
Yep, I'm here. Can you hear me?
Yep, we can hear you. Right.
Yeah, I think my internet is being a little slow or something. Sorry about that.
It's okay. I've sent Seif DK in an invite. He wants to ask you questions about distances to stars. And he's got some quite good questions.
That'd be great.
Now, Buddy's getting ready to come in. You also had some questions about, I don't think we're going to get anywhere with the sky, because no matter how much evidence I give you that it's the ground moving and not the sky, you just go, yeah, but that's not what I say. Oh, we got both PhD Tony and Seif in. Excellent.
Bring it. No, I'm just kidding. Hey, sweet. I just got 2 subscribers since we started. So yeah, nice. That's cool. You guys should subscribe to my channel. FTFE should put a link in his description.
Hey, Tony, how you doing?
I'm okay. Can you hear me?
Yes. Nice to have you on.
Hello.
So I've been having a conversation with Joe here about the rotation of the Earth. And no matter what evidence I give him, he says that it's the sky moving and not the ground. And I thought that, considering the nature of a lot of your work, you might be better suited to maybe give some other evidence.
Okay, well, there's multiple evidence about the about rotation of the Earth. For instance, variations in length of day. Are you aware that the length of the day varies?
Do you mean I'm not sure what you mean. Just like that it's not 24 hours.
Yeah, it's
It's
not
like
exactly
slightly less.
24. Well, it varies. It can be more and it can be less. And actually,
I
it changes. It changes in response to mass redistribution on Earth. So if there's a large earthquake, for instance, that'll affect the length of day. The length of day, the observed length of day, will change after a large
okay.
earthquake. Similarly,
How do we measure? I'm just curious. I just am curious, just so I understand. How do we measure the length of the day precisely like that?
so the length of day is measured precisely by taking very precise measurements of when a particular star returns to a position above an observer.
Okay.
And so there's a so you can see variations in the axis of rotation. You can see that the Earth's axis of rotation is tilted in response to recent melting of the polar ice sheets. So, for instance, the Antarctic ice sheet or the Greenland ice sheet, they're losing mass at the moment. And that mass is going to the equator. That has an effect on Earth's moment of inertia and changes the rotation. You can see that in very precise observations of the stars. And there are instrumental techniques that you can use. For instance, you can put a superfluid in a torus, and the superfluid should not be moving. The only way to move a superfluid, because there's no viscosity in the fluid, is if you move the entire container and you try and make the container as precisely located as you can. And detect whether or not there's any movement inside. And in fact, you do detect it because there's rotation occurring. The container is moving, and the superfluid moves in response to movement of the container. So there are a number of different sort of experimental setups that we can use. Another way to do it is to so you can get a niobium ball and put a red dot on it. I can hear myself. Is that anyway?
What is a niobium ball? I don't even know what
So
that is.
so niobium is a type of metal. It's very useful in superconductors. So it's a very useful tool because it's highly responsive to magnetic forces.
Okay.
And so what you do is you get a niobium ball, you put a little red dot on it, and then you put the ball in a strong magnetic field, so it's just floating there.
Okay.
And you will see that during the course of the day, the red dot will move, and that's happening because of the rotation of the Earth. It's sort of a version of Foucault's pendulum, if you've heard of that.
It's just like some kind of movement that's happening very very slightly. It's so you wouldn't notice it if you weren't trying to measure it. Almost,
exactly. And this was actually one of the questions that I wanted to start with you is your main objection seems to be that you don't fit. There's a lot of large motions that sort of the globe theory suggests that the Earth is undergoing, and you don't feel them or see them. Is that a fair summary of your position?
Yeah, I mean, I think I understand what you're saying, and yeah, I guess that I have a hard, like a lot of the observations we make and with this equipment, and some of the stuff, it obviously points to that there's some kind of motion happening, right? And so I'm not denying that or rejecting that idea, but that's one of the only ways that we measure something that goes completely against what we experience and observe daily with our bodies. I'm saying, and I'm not saying that we're more accurate. Like Red's Rhetoric made a good analogy when he said, Joe, you're a carpenter. Do you use your eyes to measure how wide you're going to build a cabinet, or do you use a tape measure? I use a tape measure. So there, I understand that, but a lot of things that we can observe when we do science or whatever experiment or use instruments and things to measure things, we can say, oh, like the microscope is a good example, I guess. It's not going against what we observe daily. Do you get what I'm saying? It's just not going against it. The way that the rotation is measured with the equipment in different ways that they measure it.
Okay.
It you know what I'm saying? It's only because it just is opposite of what we experience.
Well, it's not necessarily the opposite of what we experience. It's just that sort of a lot of these effects, we're only really sensitive to accelerations.
Yep.
If I put you in a train, you wouldn't be able to tell me how fast the train was going, as long as it was going at a constant velocity. And the laws of physics in that, and the laws of physics in that train would seem the same as if you were standing still. So there's just no way of knowing, and it doesn't matter how fast you're going. So all we're sensitive to are the accelerations, and the problem is that the accelerations involved in, people can make it sound like, well, there's this huge acceleration that's occurring. It's a really tiny acceleration. It's a tiny fraction of gravitational acceleration. So we're just
it's
not
in like the
sensitive to
outward I'm sorry to interrupt you. That would be like in the outward acceleration, and that's being canceled out by the 9.8 seconds or meters per second squared.
Yeah.
And then that would be hard to measure anyway. But
but we do measure it. So and in fact, we can do a lot of more detailed experiments. So there's a thing called a gravimeter. I'm not sure. Perhaps if I gave you a presentation about how a gravimeter worked, would that be useful to you?
I think, is that an instrument that you would have on like a smartphone?
Well, a smartphone has a network of accelerometers, and a gravimeter is indeed a form of accelerometer, but they're very sort of the top class ones are extremely sensitive. So they can.
Would that be like a magnometer or whatever?
Magnetometer? No,
I don't know.
Not really. So there are gravimeters. There are different styles of gravimeters that use different physical phenomena, and some of them are superconducting gravimeters, for instance.
Okay.
They have a niobium ball again. Niobium features heavily in these superconducting experiments. What they do, if there's any movement of the ball, there's a current that is produces a current in the superconductor around the ball that forces the ball back to its original starting position. And so by measuring those currents, you can reconstruct the forces that have been applied to the ball. Now, for this experiment for these instruments to work, you need to freeze the interior of the instrument down to about 12 degrees Kelvin or 12 Kelvin or lower, and so there's no air in there. And these things are in filthy great metal canisters, so they
have to be what's the word I'm looking? Isolated, right?
Yes, they have to be isolated, and that's one form of gravimeter. There are other gravimeters that are that work on different physical principles, like dropping a test mass and just bouncing a laser off the test mass as it falls and seeing how quickly it falls. And these things get extremely sensitive. So that last one that I described, dropping a test mass with a corner cube on it, they can detect the change in, if you do a test of gravity and then you move them upwards by 20 centimeters, they can detect the change in gravity.
It would be interesting to do some of these on the space station to see some of these things, because there might be results that we haven't thought of. You know what I mean? Or I guess we would think of it because we would expect certain things in zero gravity.
To be technical, on the space station, for instance, you're not actually in zero gravity, you're in microgravity.
Yeah.
And so you're just constantly falling in that particular circumstance. But I'm pretty sure that there are gravity experiments on the ISS, but actually we have satellite missions that do gravity measurements for us.
Like
So
fire, like how fire is it doesn't know what to do in a state of free fall.
Well, so the work I do is involved with the GRACE satellite mission, which is the Gravity Recovery and Climate Experiment, and in that case, we use satellites to measure changes in mass on Earth's surface, the mass distribution on and within the Earth.
In different areas, or
in different areas. So
okay.
These two satellites are circling the Earth, and they're firing a laser backwards and forwards and measuring the distance between them. Now, if you imagine that there's something heavy on Earth's surface, then the lead satellite will accelerate towards it, leaving the second satellite behind. So the distance will increase, and then when they catch up, the lead satellite will slow down because now the heavy mass is pulling it back.
It's just measuring the differences.
Yeah, so it's measuring the distance. Yeah, it's measuring the distances, and from those we can measure the the relative velocity and the relative acceleration of the two satellites. And it turns out from those we can construct an extremely accurate measurement of surface gravity. So we can detect things like heavy rainfall, for instance, or if somebody, the Nine Gorges Dam, I'm pretty sure that has a gravitational signal that can be picked up by the GRACE satellites. So, it's extremely sensitive. We can even pick up the mass redistributions in response to earthquakes, for instance.
Do you mind if I ask how does it, I guess I sort of understand. I'm a little slow sometimes with new things. I'm just trying to understand, so I'm not like faking my way trying to. Do you know what I mean?
Yep.
So it's basically using two pieces of equipment and using like the different, or it's using a laser, right? Is that what you said? A laser?
Yeah.
Okay, and it's just measuring the difference in
the distance
between the two as they orbit.
Yeah,
okay.
That's right.
Okay, that's cool.
And it's more complicated than I've made it sound in this sort of simple.
I'm sure.
There are star cameras that need to be corrected for, and antenna offsets and wobbles and particular forces that are. These things are actually sensitive enough that you can detect sort of the thermal radiation. So when they're in the sun, not only is there the radiation pressure from the sunlight that is forcing their orbits, but once they pass behind the Earth, they now start radiating the heat away. And
because
the radiation,
they're in the dark.
Yeah, because they're in the dark, they're radiating the heat away, and we can actually detect that.
Okay.
In the data that they give us, and we try to remove that if we can. So there's a lot of, one of the problems with science is that there's a lot of very technical stuff that the average person just doesn't need to know. I mean,
and you couldn't even know all of it. I mean, like there's
exactly.
Like, you could spend a whole career working with those satellites, the grav, whatever you call them, I can't remember.
GRACE.
But and all you could spend literally your whole career.
Yep.
Studying and understanding the fine details of the very specific things, and you can explain it to someone, but while you're explaining it to them, you're also well knowing in your head that they're not going to grasp the things that you're not going to tell them certain things because it would just be pointless unless they're going to spend their whole career doing it.
That's a really, really good point. And I'm glad you brought it up.
And I always say, oh, go ahead. I'm sorry.
No, go ahead. I just wanted to say that was a really good point that I wanted to bring up, and you got there first. So thank you for that.
I always find it kind of interesting where there'll be something that I've never heard of, like it could be something with car tires, or it could be something very simple, but something I've never heard of. And I go, oh, I didn't know that people did that. And if you look into it, you find that there's a whole industry of many people that have spent their entire lives studying and writing and making data, like making media and things that for people to watch, and then like, wow, I just heard of that right now, and I've never heard of it before, and someone else has spent their entire career and hasn't even covered all the bases of it.
Yeah, that's exactly right. I mean, science is now so vast and so complicated that that people end up very specialized, and it's just sort of a lot of the flat earthers say, well, I want this experiment done in front of me. Well, you don't have the equipment, and even if you had the equipment, you wouldn't necessarily.
You wouldn't believe it.
You wouldn't.
You'd ignore it if you had the. It was right at your fingertips. The flat earthers would ignore it. Now, see, there's something that, I just have to bring this up now, and it's kind of unrelated, but I have to say it. I don't understand it, but I definitely want to know the truth about whatever situation things that I'm wondering or debating or whatever. I want to know the truth. And what's interesting to me, and I don't have an answer for it, but when I'm looking at the aerospace industry, and I kind of vent or rant about this a little bit, because I see all the flat earthers, because globe busters or whatever, and I love all them guys, but I'm just saying I see them taking an approach to something when we all know that the flat earthers they're pretty proud of the research that they do to find the truth, right? And I'm like, why did they close their eye? It's like they stick their fingers in their ears, close their eyes, turn around and say, la, 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 I'm not listening. Yeah. When it comes to the most advanced technology that humans have come up with.
Yeah.
That humans, the peak of our technology, and they have to ignore it.
Right. I just want to introduce also Scythe. Scythe DK, you there?
Yeah, I should be.
Oh.
Hey, how you doing?
Hello.
So
can I add something to this?
You wanted to ask a question about rotation, didn't you? I wanted to get you in before we moved on from that.
I've actually asked FTOP about this before. Have you ever tried, like, let's say your Dobsonian telescope, pull that off, put your camera on it, turn it around and photograph a light in the sky? Does the light move when you move the camera? Do you make star trails?
Do you mean like as I'm moving the telescope or with the camera on it?
Yeah, just spin it around. Does that look like you're making star trails?
It would appear that way, I bet.
Exactly.
I've never done it, I guess.
Exactly. So you can't actually say, we have star trails, so the stars are moving. It could just as easily be you moving.
Well, of course it could, but let me ask you a question. Do you observe the constellations changing throughout the year and the stars moving every night? So that's the simple point I'm making. I'm not arguing with the other point that
actually that's because of the orbit. So I only see Orion in the winter, because in the summer it is in the sky, but it's in the sky in the daytime.
Yes. Yep.
Yes.
I can only see Jupiter and Saturn for half the year.
And another thing about the whole Neptune thing, if you actually calculate it, because we know the distance to them, it is moving faster than the speed of light.
And I take a different stance on whether we know the distance to them or not. They're not tangible to me, but
okay. So you have some cameras. Have you ever heard about I don't know, Leica cameras?
Which kind of cameras?
Leica.
No, I have not.
Have you not? Okay, so they're like $10,000 cameras. If Parallax doesn't work, this doesn't work.
Okay. But
because
Parallax,
can you see
Parallax
my
doesn't
screen,
mean that. Oh, I'm sorry. I cut into what you were saying.
I need to say this. Okay, so you see here in the corner, that's the viewfinder. Here's the lens.
Yep.
This makes a parallax error when you focus. So they have to
very
add
slight,
a
but
second,
yeah, I see what you're saying.
Oh no,
to
it's
make a
actually
stereo
pretty
image or
significant.
whatever?
It's actually pretty significant.
Is
You
it?
can
Well, I
yeah.
suppose. I mean,
If you
it's
use
about as wide as our eyes are from
no
each other. So yeah.
no, if you use like a lens at f1 1.4, let's say like an 85 millimeter lens,
Mm-hmm.
the depth of field at like 2 meters is 1 centimeter. If you're off by 1 centimeter, you're out of focus. So
Okay.
if parallax measurements don't work, they can't sell this camera for $10,000.
Okay. But again, it's an observation that's made from the ground, right? Is what you're talking about. The
Yes.
parallax, I mean.
Yes.
So is there, and I guess I'm not experienced with these cameras. I've never heard about them or whatever, but I understand what you're saying. But at the same time, it's just something that we're viewing from the ground, right?
So
And what I would say is if there was an
actually,
airplane in
actually not anymore, because there are satellites in orbit that are
yes.
tracking the parallax of distant objects.
Okay, so if we okay, that's a good point. So
Because
if we look
there are just one thing, there are atmospheric conditions like atmospheric. I think it's called atmospheric aberration
yeah.
that actually skews the view from Earth. So it's actually better to
Yeah,
have
I
them as
agree.
satellites.
I
But
agree.
you
We're
can
looking
correct.
through a lot of stuff.
You can correct for that. But anyway. Go
Okay,
on.
so if we're looking at let's just say if we're looking at the ISS flying over, and we could measure, we can triangulate and measure the approximate height or distance that it is from us.
I
If we have
believe
two points on the
Rhetoric
ground.
has done that. I believe Rhetoric and Astronomy Live
Has done that,
they've
yeah.
done that twice now.
And I
Yeah,
think
they've done it
it's
twice
quite
now.
a simple. I think it's quite a simple thing. But to me, when
Oh,
we're
yeah.
when we're measuring that, I think that's more of a tangible measurement than a star would be, because I just see the stars to be.
Oh,
I
well,
go ahead.
that is true, because like the I think Slicebar Kane did a video on this a few years ago when he did his Eratosthenes experiment. You need like at least 13 or more digits after the comma on the angles, because if you like round it off, you can actually be off by quite a lot.
Bit. Yeah, I agree.
Yeah, because the angles are so small. So like,
And then
let's say
that also
0.01 and
sorry, that also is affected whether the Earth was a flat plane or if it was a globe too. That really affects that too.
well,
The distance.
why would a star be? So do you think that the universe zips on by at like multiples the speed of light?
I don't think that it's a big universe. I see it to be more of more local, I guess. The stars, I'm not saying that they're right here or something, but like we have geostationary satellites that are 25,000 miles or something,
Yeah, but
right?
here's the thing, though, you're actually contradicting yourself.
Okay.
If things are closer, the parallax angles will be greater.
Uh-huh.
Yeah. You'll see the
Alpha
difference
equals
more
2 times
as
the arc
far
time.
as
Yeah, so
If-
if we have a
the closer
close-in
they are to you.
if we have a close-in universe, we would actually be able to notice that even more with parallax. The fact that the parallax angles are so tiny demonstrates that it's a very large universe.
Well, and that's where
Um,
I guess where I would differ the way I look at it, because
Um,
I don't. Oh, go
I
ahead.
think
Greg.
I think Tony, didn't you talk to me before about a really good measurement of a really good way of measuring distance to stars? Was that you or was that Phil Bell? One of the two.
I think it might have been somebody else, but I mean, you start with parallax, but then you use the standard candle technique to get those distances.
What is that?
So there's a particular type of star called a Cepheid variable,
Okay.
and it undergoes cyclic variations, and somebody was able to work out that the luminosity of these stars is directly related to their frequency, and so if you've got two of these stars and one of them seems a lot dimmer than the other, but they're they're the same frequency, then you know that that one's much further away. So because of this sort of technique, you can start getting a distance scale on the on the size of the universe as a whole. It's one of the, I think it was one of the breakthroughs that sort of allowed people to work out that there were in fact multiple galaxies. Was through this Cepheid variable technique.
Okay. And that makes sense. But when I'm looking up at the sky, like whether I look just with my naked eye or the telescope or whatever, what I understand is that you guys are basically looking at however far you can see anything that we can see up there, satellites or anything up there, that we can use these techniques that we know work on the ground, like triangulating and things, just with simple geometry, I think. But when I look up there, I don't see those to be physical in the same way that things are on Earth, I guess.
Why does something need to be physical for us to measure its distance?
Well, that's the same.
I guess what would it be? What else would it be if you're going to measure its distance? Do you know what I mean?
I don't know. Is it something that I'm just seeing inside my brain? Like,
no, I think it's the sky. Like when there's no more air, basically, when we're out of the air, which is a very, I guess, in comparison, it's a low elevation compared to what's above it or whatever. But I don't see that to be the same nature of things. Like I see it to be light and not to be like. Well, here's an example.
Okay,
what is in the blackness of space?
Question. Can I ask you a clarifying question about your position? When you say it's a different, experience, are you literally saying that there is a different fundamental law of physics up in the space than there is down here?
Exactly. You could almost say, and I know this is like general, but you could almost say that physics, the way that I see it, physics, and I can give you lots of examples of why physics doesn't exist in the same way at all. In space where there's no air.
I imagine Tony's having a little stroke about now.
How can you demonstrate that? Can you even demonstrate that hypothesis to be true?
I would actually go in a completely different direction. So let's just stay on Earth and let's ignore everything in space. Okay, let's concede that that's true. I can still prove that the Earth is round, right? Without any reference at all to celestial objects.
I'm sure that there's lots of ways that you feel that you could.
It's not a matter of feeling; it's a matter of being able to demonstrate it. I can look at the, from the laws of physics. Have you ever fathered a child? That's a personal question, but have you ever had children?
I have not.
Okay, but you are aware of a thing called ultrasound that can be used to inspect a fetus while it's still. Okay, so that's essentially how seismology works. And we've tested the concepts of ultrasound on small objects. We use them on machinery. We use them on bolts. We use the same techniques as we do for seismology on the transport of sound in objects that we completely control. And then we can use seismic waves to explore in oil fields and for mineral deposits. And then we can look at what's happening with a large earthquake, and we can detect the travel times for a large earthquake. Now, for a particularly large earthquake, there's a type of seismic wave called a Rayleigh wave. And they're quite unusual because they actually make multiple circuits of the Earth.
They kind of go around and around.
They go around and around. Now, if the Earth was a disk, they would bounce off the edge. They would lose their coherence, and they would start they'd just be.
They wouldn't be measured. You're saying they wouldn't be measured the way they are.
Yeah. Now, also, we do have flat Earth seismological models. In fact, I analyzed them. I used one in my PhD thesis and adapted it for a viscoelastic medium. But the but they don't work. They stop working once you get over a large enough distance. They stop being accurate, whereas the spherical models stay accurate. And you can look at the patterns that occur in seismic arrival times, and we have tens of thousands of earthquakes, tens of thousands of seismic events that we have recorded, whose fingerprints we have, and they all tell us. We also have many thousands of seismic stations that have recorded them
all over the place.
Yeah, and so we can look at that data and we can say, if the Earth is a disk, for instance, imagine an earthquake that's just on one side of Antarctica, say the Macquarie earthquake, which I think was in 2004, Christmas Eve. That was on Macquarie Rise, which is just near, just below New Zealand, so on the eastern side of Antarctica. The energy from that earthquake got to the far side of Antarctica very, very quickly, much more quickly than it got to other portions of the Earth. Now, how is that possible? If you look at it from above the epicenter, you can just see the energy rippling outward like a ripple.
I think I understand what you're saying. Like if at that point by New Zealand or whatever, if that was going to move through the Earth or whatever, then it would kind of be on a flat Earth with like an ice wall type of idea. It would kind of be like the entirely opposite side that it would be going to first. I think is that what you're saying?
Yes, exactly.
And I interject with a quick fun fact. That's how the Danish geologist Inge Lehmann found out we have two cores of the Earth.
Yes. So
two cores of the Earth. Wow.
So there's an outer core and an inner core, and actually there's been a recent discovery that there's,
I was going to say they think that there's a layer outside the outer core that has a higher density than the layer underneath it due to convection currents. It was really quite interesting to learn.
Well, there's the D double prime, but I think there's additional structure in D double prime layer is the layer that's just outside just at the core mantle boundary, but the inner core seems to be exhibiting some structure as well. So there's but of
course we all know from the recent Godzilla versus King Kong movie that there's an entire hollow Earth, so we need to take that into account, right?
Oh yeah, I heard about that.
Monkey win.
So it's just that sort of we've for more than 100 years we've been studying earthquakes as precisely as we can, and there's just no way to reconcile the way they work with a spherical Earth. Are you aware of the Krakatoa eruption of 1883?
I've heard of it. I mean, I've never researched into it.
So at 100 miles away, the sound from that was 140 decibels, I think.
And that was from like an eruption, or was
that was from a volcanic eruption. So the pressure wave of that air again circled the Earth. Well, it circled the Earth multiple times. You can see it in the air pressure records. There's this pulse of high pressure, and it circles the Earth, and it doesn't do it in the way that it would. If the Earth were a disk, it would get to the edge of the disk and it would bounce. And it would meet the edge of the disk at different points in time, so it would lose coherence.
I was actually reading a paper about it, and the way it would work on a flat surface, you have to start taking into account chaos theory really quite soon to be able to try and predict where they would go. And there's so much interaction between the seismic waves themselves that it cancels out a bunch and then makes others expand further, and it
just like waves in water
to predict
exactly
the way that you can with a sphere.
And so so we can leave space aside. Let's just leave space aside. Let's just leave the optical evidence aside. Let's just leave cameras out of it and lens effects and refraction and whatever. Just looking at the Earth, just looking at the data we have, it's not possible. It's not possible that the Earth is flat. Without any of this without any complicated, physics in spaces, or whatever, we can demonstrate emphatically that the Earth is around. And I mean, millions of lives actually depend on us being able to do this. So
and there's also there is another, and I'm not trying to like argue with you, because it seems almost pointless to argue some of these things, because like I live by a lake that's almost 20 miles across, and I can put if it's a calm day and it's not windy out, I can put my camera right on top of the water and I can see the other side of the lake, the shore. I mean, not the shore itself, but like the trees on the shore, almost 20 miles away.
And so the optical
horizon thing doesn't seem to work in that, and so they're
one of the reasons I would suggest against using optical evidence is that it's very complicated correctly interpreting it, because you need to know all of the atmospheric conditions, you need to know the refractive indices,
I agree,
humidity and temperature and that sort of thing. And without that data, it's kind of impossible to demonstrate one way or the other. I mean, you can say, look, it's possible that the Earth is a globe, and you would get this. But it's equally possible to say, well, the Earth is flat, and you don't need those optical effects. So I kind of think that the optical evidence is inconclusive. It doesn't necessarily prove the case one way or the other.
And I can agree with that to a certain degree.
Though I will say, if you haven't checked out Ranty Flat Earth's recent photograph, the one that
I saw that, and it doesn't.
Thanks,
really,
Bev.
It doesn't really convince me. Really, if if we're looking over land, that's going to be hard anywhere on the Earth, because of the what is it, topography,
Yeah,
but water would be uniformly.
Let's go to Denmark.
Spherical.
We have no topography.
Yeah, it's just flat. Oh wait, shit! Don't say that.
So it's difficult in the sense that sort of over water, yes, you've got some effects, but you've also got refraction. Refraction is at its peak over water. Also, water has the behavior of water. My particular field of study is actually sea level change. And so sea level change responds to the rotational characteristics of the Earth. It responds to wind, it responds to tides, it responds to currents. There's a thing called the Atlantic Meridional Overturning Current, the Gulf Stream. And the water is higher there just because it's sort of pumping hot water out. It's sensitive to salinity. It's sensitive to temperature. It's sensitive to
the temperature.
Land motions. There's just a vast amount.
And the temperature of the air versus the water, that'll make it move around a little bit.
Well,
too.
air pressure, certainly it is sensitive to.
Or that'd be pressure, I guess. Yeah.
Yeah. So if you make the air pressure lower by making the temperature higher, then you will raise sea level, and that's how you get storm surges, for instance. So it's just, we talk about water as though its behavior is very easy to understand, but in fact it's extremely complicated. And
depending on how technical you want to get,
and
or
depending
how
on how
precise, I guess.
Yeah, how precise you want to get, like trying to detect millimeter per year changes in global mean sea level, for instance, requires that you take a lot of stuff into account. And even people in the scientific community don't seem to understand just how sensitive sea level is to various indicators. So using water is fine, but actually the fact that topography doesn't have these complicating factors and doesn't have these potential dynamic effects or refraction effects kind of does simplify things a little bit for us. But regardless, this is one of the reasons that I stay clear. I don't know as much about optical effects as Seif does, for instance, or a lot of other people in the community, because these people are highly trained professionals with years of experience, and my experience is different, my expertise is different. So I tend to stick away from that, but I do still feel that I can prove that the Earth is round without any of this, without any optical data, without considering a refraction, not refraction of optical waves, anyway, of light waves. It's just and there are other forms of evidence you can use, surveying techniques of various kinds to demonstrate the curve of the Earth. And the simple reality is that there's a particular formula for the distance between 2 points on the surface of the Earth. I think it's called the Haversine formula. If you want me to start,
pilots use
if you want, all you need to do is find 2 points where that isn't a pretty accurate metric of how far they are away. And it doesn't matter if we measure that distance using planes or boats or cars or walking or weather systems or seismic waves or tsunamis. Always the distances work out well, given the velocity of whatever it is we're using to measure those distances. So it just seems that's a fundamental constraint, and again, it doesn't involve any optical. You just set out traveling from one point to another at a particular speed, and the time you take to get there will depend on the velocity you travel at and the distance between you, according to the Haversine formula. And it always gives an accurate result. It's how they calculate how much fuel to put in a plane, or how much food they needed on a sailing vessel,
or how much fuel I needed to calculate to get my submarine from point A to point B.
Exactly. Yeah.
And just on that, the only time I've actually heard about that fuel thing not working is when they accidentally screwed up the conversion for liters to gallons, I think it was, at an airport, and an airplane ran out of fuel.
Yeah.
Yes. That's
well,
right.
that would just be a mistake, though.
Yes, that was just a
Numbers are
a
important.
mistake. They changed the model of fuel, and there was also a glitch with the computer. I can tell that Seif watches air crash investigations, or he's remarkably well informed in some other way.
I actually quite like watching those.
Yeah, so do I.
Interesting.
I really enjoyed
I
that.
tell you
what,
the YouTube rabbit hole lead me to some crazy things, because I was looking at air crash investigation stuff last night after originally looking at a dog chasing a rabbit. I mean,
right.
Hey, the suggested videos, sometimes you'll end up in some strange places. You'll become a flat earther.
I know.
Can I ask a question for FTFE?
Well, I was going to say I want to finish in about 20 minutes, so I would like you and Tony to have a couple minutes each to ask any other questions that you have, and then I'm going to ask the super chats. Okay, so you first, then, Seif.
Yes. So I had earlier in this conversation, you talked about how you don't think we should use instruments because in the conversation about what's it called, gyroscopes. So have you ever had a broken bone?
I think so. Yeah, I've never had like a.
What
I've
do you
never
mean you
had
think so?
a
That's something you would
cast
know
or
about.
Did they cut you open to find out if it was broken, or did they use an instrument?
They use an instrument. Yep, an X-ray or whatever.
Yeah, and I've seen my brain on an MRI machine. They didn't have to cut open my brain to find out what's wrong.
Mm-hmm.
So why wouldn't you trust an instrument in some cases, but in others you will trust them?
Well, it's a good question, and I'm not, I'm not trying to be disingenuous, but I am pointing out that when you went in the MRI machine and it photoed however it works,
it's magnetism, and it makes a lot of noise. It's
or when you did
really
like an
loud.
X-ray, or these types of things are on the same kind of area as a microscope with like a viruses or something like that, where
well, they are.
Well, what I'm saying is that doesn't go against anything that you're observing normally or daily.
Actually, it does. I don't observe my brain daily. I don't observe my bones daily, but I can see them using an instrument.
Agreed. True. But if you were, it's hard to come up with an analogy about like the brain or something, but if there was something that you saw on an MRI that went against something that you were observing in a different way.
Oh, you mean like,
that's where,
for example, I have a cyst, an inoperable cyst in my brain that might actually be the cause of my chronic headaches, like that. Like, I don't see the cysts, but I feel the effect
but
of
you feel it. Yeah.
Yeah, but I don't see it and I don't feel the cyst
So if you
itself,
do an
I feel the
MRI and
effect
then
of
you
it.
see the cyst or no?
Yes, exactly.
So then that would be in agreement with your headache, or at least it would be an assumption that that could be why I'm getting a headache.
Not necessarily.
It's not going against it though, right?
Well, I don't see the cyst itself, but I see its effect.
Yeah, just like I was saying, we can see the effects of the rotation of the Earth quite clearly in the world around us.
And we can also see the effects of the rotation of the sky by simply going out and looking up at the sky.
No. all you observe is that the sky, the things in the sky appear to be moving. You don't observe the rotation
I've actually,
of the sky. I think Tony wants to say something there.
I've actually tried to explain this to FTOP once. So you know why they launch for normal orbits? They launch near the equator, and when they launch for polar orbits, they actually launch further up north or south because they need to shed the velocity of the Earth.
Yeah,
it's a polar
orbit. That. Yeah, they launch to the east, right? Or is that right? The east? I'm not thinking right. Yeah, they launch to the east, like from Cape Canaveral. Yeah.
So if the Earth isn't moving, why do they need to shed the movement of the Earth for polar orbits?
I don't think that I fully understand all of that. Like that's something that
there we go. That's perfect answer. Well done.
That's something that I'm trying to learn more about is like how the space station, it has its trajectory and how it moves throughout the month or whatever, and you can't see it. You can only see it about 20 out of 30 days.
I would actually like you to go and do something after this. Have you ever heard of Cool Hard Logic?
Cool Hard Logic?
Yes.
Is that a channel or something? Or
yes. In one word. He has he actually has a series for it. It is for geocentrism, but he actually explains why it's absurd that the sky is moving. Because do you have any idea how the sun would have to move for the sky to be moving? Like it would be. He dubbed it crazy.
But remember,
spirals.
Scythe, he thinks that there's completely different laws of physics up there. So
yeah,
well,
but
I think
that doesn't explain how
just hanging there, or it's just sitting there, but it's moving.
I think Tony's trying to speak. So what's that for you? What's that, Tony?
So you are aware, right, FTOP, that there is that the stars are not stationary relative to one another, right? That they do show movement.
Very slightly, right?
Yes, it is slow, but there is proper motion. There is.
Are you saying like throughout, like over a century or over a millennium or something? You're saying?
Well, it's detectable. It's detectable. If you just take photographs a few for a few years apart, you'll be able to see the difference. In
very small difference. Yeah.
Yes, very very small difference, but a difference nonetheless.
Yep.
If the Earth, why? If the stars are, so you're saying that what we're looking at is just the rotation of the stars, but the stars are maintaining a fixed configuration, only they aren't. So why does this simplify your model? They do move relative to one another. The planets move relative to the stars. Comets and asteroids move relative to the stars. Meteorites move relative to the stars, and they hit Earth. We observe other planets being hit by these. You can see the Earth, you can see the sun rotating with respect to the Earth. You can see the sun's magnetic field rotating with respect to the Earth. You can see the sunspots moving across the face of the sun.
Yeah, you can see that it's turning, or it appears to be rotating or whatever.
Yeah, but why? If if you're, for instance, in America, I'm in Australia, why are we both seeing the same side of the sun? Is the sun a disk or is it a ball? What's going on? If it's a ball, why am I seeing the same side of it as you are?
Well,
and why aren't we seeing the poles of
believing
this sun?
that I don't. I'm just telling you my belief here. My belief is that it's a disk type of thing that's the same size as the moon, which is
Wait, whoa,
I think a disk.
Hang on.
Wait,
Is the moon a flat disk?
I don't know. I couldn't tell
Because
you.
you
I know
do know
it,
that
it
we
appears
see,
to
like,
be a sphere.
No, yeah, it appears to be a sphere because we see from Earth, we see, is it 54 or 56% of it?
Yeah.
it
Yeah.
changes.
Libration, is that the
Yeah,
that the
yeah, I
technical
think
term?
that's the word I was looking for. Even throughout the one night, you can see the change in the amount that you can see based on the wobble of the moon. But yeah,
Okay.
it's averagely about 54%, I think.
But
But if
my
Oh, go ahead. Sorry.
So it can't be flat.
my follow-up question for FTUP is where is the limit on this conspiracy? So clearly, if the Earth is flat, the information is being hidden from you. What is the extent of this conspiracy, and why does it exist?
Oh, I'm
Can
glad you
explain
asked.
that?
I'll try to say it, with time in mind here. I don't believe there's a conspiracy at all.
Wait, what now?
So I'll explain what I mean. I do believe that we've been born into a world that's been misunderstood about the nature of the stars and the nature even of the Earth that we're on, and that the conspiracy, if there was a conspiracy, it's not men that are, it's not human beings that are conspiring together to lie to anyone. And this differs from other flat earthers, and I get a lot of crap for saying these things, but this is something that I believe, and it comes out of the Bible. But it's something that I believe that NASA is not an organization that's lying to the world. SpaceX isn't lying to the world. They're not lying about anything. They're doing the things that they're putting out to the public. It's very simple. It's just the aerospace industry. They're trying to reach certain goals, and I believe that that's going to be a problem in the future. But that's another subject. But I don't think there's a conspiracy.
Can I interject?
Yep.
I need to interrupt because you're actually contradicting yourself again.
Okay.
If NASA isn't lying to us, then you're accepting that they did go to the moon. If they went to the moon, it means Newtonian physics work, which means physics works in space.
It gets a little complex, and I understand why you think that, or why you can come up with that. I'm contradicting myself, but
can I make an observation?
Like the moon?
That is how it sounds.
Go ahead. Well, I'll explain it after Tony.
So, when we talk about Newtonian physics, Newtonian's theory of gravity is based on the motions of the planets, right?
Yeah.
It's not based on any earthbound observations. It's based around the observations of planetary motion made by Tycho Brahe and Kepler.
And Galileo was kind of the
stop.
So
Tycho Brahe, not Tycho. Tycho.
Oh, sorry.
Yeah, I say that wrong as well.
Everybody says it wrong.
All I can say is that Danish people need to learn how to spell. But moving right along, there's a
I agree with that.
It cannot be the case that Newtonian physics doesn't apply in the two planets, because
you're saying because like we have the lunar reconnaissance orbiter and we have all these.
because it is designed to explain the motion of the planets.
Okay.
That was how it was developed, right?
But they go in the pattern that they go in what am I trying to say? They move in the manner that they move, right?
Yes,
because of elliptical orbits.
And Newton came up with Newton was able to come up with the mechanism by which that occurs, and he was able to describe it and reconcile those observations with his theory.
And predict with it and everything.
Yes.
Tony, can you imagine locking yourself in a room for 5 years and inventing a new math just to win a bet?
Oh,
Come
I'd do
on.
it. I'm just kidding.
That sounds like something I'd do, actually. No, I'll fucking win this bet. Screw you. All right.
Can I
Okay,
touch on the?
Yeah,
Are we?
quickly,
Are
and
we?
then we're going. Well,
I
quickly,
just want
respond
one
to that, and then we're
comment.
going to move to super chats.
Okay. What I was saying about Seif was saying how it sounds contradictory to what I'm saying. I don't actually. I just lost my train of thought about where I was going with that. So forget it.
Never mind.
Never
Okay.
mind then.
Tony and Seif, thank you for coming on. I do appreciate it. Good to see you.
Thanks,
Tony.
guys. Nice to meet you.
Nice to
thanks
meet
for
you
having
too,
us.
F-Top. Take care.
I'm gonna read
You
super
too.
chats, and then
Yeah,
we're gonna get.
I'll
out of
leave
here.
too. Bye.
Okay, speak to you guys later. Okay, I want to say thank you, F World. It's always a bit weird when you come on because we have a civilized conversation, which is completely not normal when
Abnormal.
talking to flat earthers.
I don't want to have any other kind of conversation. I mean, there's no reason to have another like there was that one guy named Jason or whatever, Fred Durst. That guy.
Yeah.
That was like the peak of I could not. I was
Oh
like,
no, you
Craig's
wait. Tomorrow, MC Toon has a guy called Roberto Reeves on his channel.
Okay.
And if I was to describe Roberto as a piece of shit, I would be doing a discredit to pieces of shit. So tomorrow is going to be something different on MC Toon's channel. I honestly can't wait for that.
When I was watching Fred Durst, I said, "Whoa, Craig's got a lot more patience than I gave him credit
I've
for."
developed more
Like,
patience. Although after speaking with you guys, honestly, sometimes I go and bang my head against the wall several times.
Hey, I understand. I do too, Craig. When I'm talking to the average flat earther, and I'm not ripping on them, I'm just saying that there's a lot of things that they will not consider.
Yes, like evidence, for instance. Anyway, thank you guys for watching. I hope you had a decent Monday night debate. I always love doing this and hope that I can keep doing it for years to come. I know that a lot of you have supported me with super chats, and that's mind-blowing as always. If you're not able to support me financially, the best way that you can help the channel is obviously smashing that like button, but sharing what I do, my streams and my videos on Facebook and Twitter, massively helps the channel. Raven Zero for $2 says NASA Mini dropping another planet was such a milestone. Yeah, once again, congratulations to the NASA team that flew a powered machine, a powered craft on another planet for the first time. Absolutely incredible achievement. Amazing. Sparky NJ $5 says, I want to talk about my question. What was your question? Sorry, Sparky. Philhammer 335 for $2 says, I feel it. It's time for fight second loss. Just to be clear, I didn't really lose to Mallory. More that Mallory broke me by showing me foot fetish furry porn as evidence for the Earth being flat.
That was the weirdest. That was strange. The whole Mallory thing. I was trying to figure that one out.
I wasn't sure what was happening. I felt like maybe I was having some kind of fever dream. I woke up like a couple
it was kind of
like,
a
was I high?
So I got the dumpster fire going with Craig in there just for fun, just so you know.
Richard Pouset for $2 says stupid started early conservation of momentum, man. Yeah, I think maybe we can have another specific talk about the things like conservation of momentum and physics of things that are on Earth, because like Tony said, we don't need to go to space. I'll arrange that with you. Connell Silver for $5. I asked this before, effed up. Why do you believe in bacteria when you cannot perceive them without a microscope and instrument?
I think we kind of discussed that in this show.
You see that as an extension of your eyes, but I mean that doesn't.
Yeah, if we look closer at something, then we might know more about it.
Every way, you know. But anyway, Richard Pouset $5. Two questions, Flerf. One, does the South Celestial Pole exist? Is there a point? Yeah. Okay. Two, if the stars just rotate around Earth, why does Orion and Scorpio rise and set throughout the year?
All the constellations change throughout the year.
Yeah, but why?
That's how we know a year. Because when they come around to the same position in the sky, that's how we mark a year, isn't it? 364 5 days.
Why? How? Why is it doing that? That's this question. Why does Orion and Scorpio rise and set throughout the year? What's causing that to happen?
I couldn't tell you why. That's the nature of the sky. That's what it's done for as long as men have
the
been
magic physics that you're
recording
talking about.
history.
Yeah. Conor Silva for $5. Effed up, long on intellectually dishonest nutters, short on evidence or models. But since he admitted he prefers his lies, are we surprised?
How do I admitted that I prefer my lies? What does that mean?
Well, he thinks the flat Earth is a lie and that you prefer it.
Oh, okay. Yeah, I consider it to be truth.
Preben Andre for 50 Nokias. I am going to be an electrician and I usually measure the current with an instrument to do it, but I'll try using my senses next time. Please don't. I do not want to be responsible for your death.
Hey, if you take a 9-volt battery and stick it on your tongue, it's really weird.
Yeah, I can tell you as someone who's worked with electricity quite a lot, especially on board military vessels.
Dangerous.
Fucking dangerous. Yeah.
Yeah.
You know, you get needed to like
nothing to mess with.
Is that live? I'll just check. Yeah, it's live.
Done. Yeah.
Yeah. Droopy Wiener £2 says, how far away are the planets, effed up world?
I couldn't tell you how far away they are. I mean, I guess. Well, how far did that little helicopter have to travel in order to test itself out on Mars? You tell me. That's how far, I guess. I don't really know. I mean, I'm sure I could Google it. I'm sure you could Google it too.
Yeah.
And I bet you'd get the answer.
Yeah, but I think he's asking for your model of reality, how far away are the planets?
Well, actually, that brings up one thing that maybe I'm glad that this is asked, because if there was the concept of a vacuum, right? If there was a actual full vacuum that with nothing in it, right? Or an area where there was nothing, how do you measure a distance in nothing? Do you know what I'm saying? Like, if you're traveling from here to there, how do you know the distance between if there's nothing there to measure? Or I know it's kind of weird what I'm saying.
You base it, you can base your distance
on time and velocity or something.
Well, time, velocity, and parallax of things around you. There's lots of ways to figure out how far you've traveled. But we can radar measure the distance to the
I don't really know how far the planets are. I mean, my assumption is that they're definitely in the sky. I really don't know how far they are.
Fair enough.
So I can't.
Free one for $5 says there are two ways to understand things correctly, and the flat Earth way. Yeah, I completely agree with that.
The correct flat Earth way.
No such thing. No such thing exists. Conor Silver for $5. Effed up. That's called double speak. You say you don't believe we're moving because you don't feel it, but you wouldn't feel it if we are double speak.
No, it's not double speak. It's that I'm experiencing and observing no motion of the ground beneath my feet. So that's what I'm saying. But you
did admit that that particular observation does not conclusively show one thing or another. Okay, you did admit.
Well,
that, right?
Same with the globe too, or I mean, same with the rotating Earth. It's not conclusive, right?
The measurements,
as far as that aspect of it,
using your senses isn't conclusive, but the measurements are conclusive.
Well, and that's where I guess there's going to be some denial on my side, because you'll say no, that's what you'll say that I'm saying, but something that goes exactly against my observations, I really have to question it. If it goes in line with my observations, then it's a lot easier to consider.
Yeah, but there's a lot more to it. Michael Hoyes for $2.15 says, effed up, explain lack of parallax if the stars are close. But you think there's a different physics up there.
I think I did.
Yeah.
I think it's just different. I think it's not, there's no physics like we have here. That's what I think. But
magic. Roby for $5 says, FTFE, will you attend SOCON next year? What's SOCON? Sock on these nuts. Got 'em. Ah, ha, ha. Courtesy of the Mobius Strip Earth gang. Mobius Strip Earth is a top secret thing. We're not supposed to mention that live. New member, Empty Hermit 29. You fucking awesome person. You. Thank you. Welcome to Scrappers. And then a super chat for $5 from him for, are we sure his name isn't effed up logic? Because that seems to be the only kind of logic he is capable of using. You don't need to respond to that one.
Well, I could talk about the word delusion and what that has to do with reality, and the fact that this is an argument to ignore the reality that we experience. So I'm trying to convince you guys that to consider the reality that we experience. So
David Keller, $5 says, the North Star is Polaris. What is the name of the South Star from the South Pole? Effed up world is a Po. Earth is not flat. Grow up. I don't think he's a pope.
I don't
I think
think
he's a
that-
very, very confused.
There's not really a
confused person.
star in the center
No,
of the
it's
south, and there's
void
really,
of
I mean,
stars.
there probably is, but what are they? What
Not
is
that
it?
we can see.
Sigma
Sigma Octantis is the closest one. Yeah.
Yeah,
Yeah.
I don't know I don't know the exact name, but
Sparky NJ
the
for
Southern
$15
Cross.
says, "Effed up world. Imagine a huge clock on your ceiling. Look at the 9. The minute hand moves left to right, clockwise. Look at the 3.
Yep.
The minute hand moves left to right, clockwise. Your direction doesn't matter." He's talking about the fact that stars rotate
but hold on,
in different ways.
we have to, if we want to understand it the way I do. Actually, Craig, if you can, I would appreciate it. I did a video right after our last debate or something, and I did a live stream, and in the chat on the Zoom call or whatever, I put a link there. And I think I think it's a clear explanation that I gave. I went into Stellarium and went to different locations and explained the way that I'm seeing that the stars are rotating. If you can put that link in there, it might help people understand.
It's a 49-minute video, so get a coffee or something, guys. But there's the link to
yeah,
Effed Up World
you don't even have
explaining
to watch
why
the
star
whole
trails
thing.
are. That could
It's
be
probably
interesting
only
to
the
watch.
first like 20 minutes of the video that you'd probably want to watch when I'm working with Stellarium. I think
Design Song
you'll
1
see
for
what I mean.
$5 says, does Flerf believe Stellarium is accurate representation of the night and the night sky?
Yes.
The Stellarium is based on a globe, so.
Well, but it's just portraying the actual what we observe from
Reality,
the ground.
yeah.
Whether it's designed
What
for a globe or not. But
yeah, exactly. It only works on a globe, basically. Empty Hermit 29 for $5 says, as thick as Effed Up World is, so far he seems to at least know how conversations work. Props for that, I suppose. Yeah.
what?
Yeah, shut up, you fucking dick, all right? Talk when you're fucking spoken to.
Come on,
that better,
man.
guys. No, do you want me to fucking mute you? Just be quiet, you retard.
You just got Craig to time me out. Now I'm upset.
Yeah, that's normally how these things go. You're a very strange flat earther. Rick Sanchez for $2 says, I will say he is one of the more pleasant flatties. Agreed.
No,
Richard Pudisev for $5 says, that flight that ran out of fuel was Air Canada Flight 143, also known as the Gimli Glider. The 767 used metric fuel tanks, unlike previous aircraft. Yeah, don't mix up the fucking units.
You know why I think here's why I'm better in the conversation.
Thompson, who couldn't work in miles.
Here's why you might be able to handle or tolerate the conversation better with me. It's because I'm not sitting here calling you all liars, you're liars. That's all I hear from the flat.
Yeah,
they just think everybody else lies.
It does seem to be the main argument at the moment that I'm a liar.
Everything
I say is a lie, and so.
And I understand that.
I would love some actual evidence from you, though, Effed Up World. I would love you to give. I would love some evidence for you rather than I think the sky has different physics. I would love to have a deep discussion about actual evidence with you.
And maybe we can zero in on that a little bit deeper. And maybe I can go into more detail about what I consider to be evidence. You know what I mean? Yeah. That's probably not. It's probably a boring conversation to go very deep because it's obvious things that I'd be pointing out, just like things that we all know.
Well, I'd hope there's some more, but anyway, we'll talk about that. Anyway, Woodchef Schmitz for 5 CHF. Your everyday experience doesn't show you the way, so you can't say that instruments are going against it. Simple logic.
Okay.
Yeah, I get that. Tono Silva for $5. Last one says, Effed Up's theory reveals his own arrogance. Everyone is deceived except Effed Up World. NASA, FTFE, the church, everyone is fooled except Effed Up World.
Well, I'm not saying that everyone's deceived but me. I'm trying to find the truth myself. For 5 or 6 years, I've been inspired to do that.
Flat Earth found it. Well done, Ranty. Not Flat Earth anymore. John Kerpan for $5 says, how does Effed Up World think a South Pole works on a flat Earth?
If you visit that link, did you put that link in there somewhere?
I did.
Craig?
I put it in the chat. I'll put it again.
Okay. That is the reason why I want people to go to that link is because that's actually sometimes you do a live stream and it seems like your point is made the way that you want it to better than other times, and that video I felt like it's an efficient use of time. I don't want to waste anybody's time.
Okay. All right. Well, well, again, thank you very much for at least having a pleasant, if frustrating, conversation. Thank you to PhD Tony and to SciFTK for coming on, sharing their particular expertise. I want to again thank everybody for watching. Check out F World's channel if you want to laugh, I guess. Sorry, nudging you.
I put some funny stuff out there.
Yeah, at least you tried to be
Simon and Dan parody and whatever. Just some fun. Yeah. Craig's on my channel a few times.
But thank you, everyone.
Okay.
Right. So here's what's going to happen tomorrow on my channel at 10 p.m. I'm going to do a little channel update, and I'm going to talk about the Sean situation. The first and only time I'm going to talk about it on my channel. I do feel like I need to put my thoughts out there about it. Explain the future of the channel going forward, regarding partnerships with anybody and things like that, and answer any questions you guys have about the channel going forward. So if you want to come and check that out tomorrow at 10 p.m, please do. That'd be great. Apart from that, I'm done for tonight. Again, thank you everybody for watching. Please smash the thumbs up as hard as you can. Don't break your monitor. More likes means that YouTube will recommend my video to more people. Share everything that I do on social media because it massively, massively helps the channel. I'm going to be back.
Bump the thumbs up.
Yes. I will be back at some point during this week with a new episode of Flerfs Are Idiots, featuring Jesse 10-2, so look forward to that. But for now, remember, stupidity is not a right. Fight the flat earth. Fight the flat. Fight the flat. Fight the flat. Fight the flat.